I'm joined today by some guest speakers, Andrea Richetta and Robert Woods. Robert joins us from Agri, and he has spent his career in agriculture, specializing in crop protection, farm machinery, and animal health, and has consulted and provided expertise to many large companies in the agriculture industry. Robert's a global citizen, originally from Australia, but Robert has spent time working for a large dairy equipment company in the US and actually now resides in the UK. And it's fantastic to have you with us today, Robert. I'm also joined by Andrea Richetta, Head of Pro Customer Success at Arduino. And Arduino is a long-time partner of OKdo, and Andrea has been with the Arduino business since 2014 and has helped manage multiple projects around the Arduino product strategy, has helped develop the Arduino PRO business, and is now in the driving force of Arduino's customer success. Arduino is known for educational technology, for technology that is deployed into innovators and startups, but the Arduino Pro technology is the latest innovation from Arduino, and I'm delighted that Andrea can be with us today to share more with everybody on this call about the Arduino strategy and technology. Before we hand over to Robert, I just wanted to take a few minutes to introduce OKdo. And OKdo is a global technology business founded in 2019, and we sit proudly as part of the RS Group. RS Group is a global electronics distributor, part of the FTSE 100, and has operations in almost every country around the world. But OKdo specifically is born out of single board computing technology. We, as a business, are a team of engineers working with customers across Asia Pacific, Europe, and North America, deploying off-the-shelf solutions, products from our partners, but also a range of services as well. We carry deep inventory to help our customers in different industry segments, and we have a broad range of partners, which I'll share a little bit more about that later on. So at the heart, sat within the RS Group, OKdo is a world-class distributor. We distribute products into countries and customers all around the world. But the value that we bring as a company, as a technology company, spans much further than that. We're now working with startups, SMEs, OEMs, and different industrial customers, offering design services, manufacturing services, and we're engaging customers through our global community, Design Spark, which has 1.2 million members, and we're helping scale our technology from our partners into a multitude of different industries, agriculture being one of them. And if we move just to the next slide. I'm now going to hand over to Robert, and Robert is going to help talk to us about precision agriculture and the experience that he has had there. So Robert, I hope you can hear me. I hope the tech is working, and I'll hand the floor to you.
Thank you, Richard. I'm sure the tech's working because I can certainly see you and I can hear you. I've put together today some slides regarding precision agriculture, but most importantly, precision farming. Now, farming relates to crop production. Agriculture relates to the whole of the industry. Just a little bit of background. Years ago, one of the first, I'm going to say, introductions for technology utilizing say, the internet and or satellite was the introduction of GPS for tractors and or farm machinery. And GPS really meant, like a guidance system for cars, it really allowed farmers to drive their tractors and the satellites guided them accordingly. Now that's going back 25, 30 years. Since then, there's been an explosion of internet-based technology as well as smartphones, PC computers, etc. So why have all these changes happened, and what are some of the challenges in running a farm, and how can these changes be adopted by farmers? So look at a couple of thoughts that I have here. Firstly, the big challenge farmers face these days is weather. Climate change is real and it's affecting farming in a big way. I've seen statistics and information to show that not only temperatures are changing, temperatures are going up in a lot of cases, which if you're growing crops such as fruit that needs a chill factor, that is causing issues. But most importantly, rainfall is changing, and the variability around rainfall, when it rains, how much it rains, when it starts to rain in countries where you have what you call a seasonal break versus a time where the rainfall stops and then harvest can occur. That is occurring in a big number of countries that is affecting crop growth in particular. Farm inputs. Now, farm inputs are all the things that farmers will buy to grow and or manage their crop. Costs continue to rise. Buying these farm inputs is a critical part of farming these days. Farmers are also price takers when they sell their product. They've got very little control over the prices that they receive because grains essentially are traded and traded internationally, and in many cases traded in US dollars. So fluctuations occur associated with commodity prices based on US dollars and exchange rates. Water. I've put down water availability, in my opinion, in the future will be the new oil. If you take the agricultural market in California, 80% of the water that is used there goes into agriculture. When there is drought or when there's issues with water being channeled to population centers in big cities, farmers start to lose out, not only in availability, but also the price of the water. So efficiency and water usage is really important. And lastly, but no means least, there is pressure on land for farming due to the expansion of city or urban areas and increasing populations. And often the best land is gobbled up around cities or towns. And we're seeing further challenges, not only in availability of land, but also in the price farmers have to pay when they want to expand their farm and buy opposing or farmers that are surrounding their farm or even in other areas if they want to expand their operation. So let's look at farm costs, because this is really where internet and technology associated with all sorts of, I'm going to call it devices, can help in terms of profitably growing crops. Firstly, what are some of the inputs that farmers need? Well, in growing a crop, you need fertilizer, you need seed, you need chemicals, be it insecticides or herbicides or fungicides. You need fuel, you need electricity, and you'll notice I put a comma there because the comma, I believe at the moment, with interest rates rising, farmers are going to be squeezed somewhat in some cases associated with debt repayments. So there are always these sorts of things that they need to consider. What is the amount of fertilizer? What's the type of fertilizer? What's the seed they should use? What's the chemicals they need for weed control, for insect control, et cetera, et cetera. On it goes. Labor. Labor is a big issue. You've got two sorts of labor. You've got labor that is there for permanent farm workers, such as family members who work on the farm. And bearing in mind that most farms these days are family farms, but you've also got what I'm going to call a seasonal labor force. And that is not only declining in terms of numbers, but also there's need in a lot of these cases to pay these people more. But you've also got what I call succession planning, where farms are then sold to other family members, or family members buy out their other family members. So there's a debt issue going on there. And farms need to be then liquid, associated with being able to service that debt and pay out family members. Machinery. To grow a crop, to run a cropping operation, you need tractors, spraying equipment, harvesting equipment, tillage machinery, sowing, etc. All cost and all expensive and need to be factored in terms of how it's run and how it's managed and how it's paid for. Last but no means least, again, is transport and storage. Grain storage on farm, or be it off farm, and transport to market is also something that farmers need to cost into the structure of growing a crop and running a farm. So the next slide will show you what is precision farming. Farming is growing a crop. And what does precision farming mean? Well, a definition I found is improving crop yields and assisting management decisions using high technology sensors and analysis tools. If you distill that and you look at the most important points, it's generating information to improve decision making and, most importantly, improve profitability. Which means then when you look at the left-hand side of the screen there, sustainable farming. Sustainable farming means that the crop or the farm will continue to be passed from generation to generation. So what are the impacts on the farming industry of utilizing these different tools that are essentially internet-based? What are the impact on running the farm and efficiently and effectively helping the farmer make decisions? Firstly, product usage, a reduction in the amount of chemical that they use and or fertilizer that they use. It's a cost-saving issue, but most importantly, the farmers utilizing this sort of technology apply the chemical or the fertilizer where it's needed. In the past, what used to happen was that the whole crop would be either sprayed or provided with fertilizer across all the land area. Totally inefficient now and totally not necessarily. Next point is, go back one slide if you could please, identification of key signs in the crop. What do I mean by key signs? If there's a crop stress that's coming or starting to occur in certain parts of the field due to, say, insect problems or nutrient deficiencies in the soil, these can be identified early before they become a major issue or in a situation where an insect outbreak can occur that devastates the whole of the crop. So these signs can be then identified and then acted upon early. Not only do you use less chemical or less product in terms of fertilizer, but most importantly, you treat the problem where it's occurring as opposed to, again, the whole of the crop. The last point there is that yield increases is the ultimate aim, but looking at all this information around product usage and identification of signs, et cetera, provides the best growing opportunities, therefore provides the best profit. And one of the other key points here is that farmers and some of the technology that they use can adjust then their seeding rates. In other words, the amount of seed that they use, they sow at the time in one paddock, and also adjust the types of seed that they use across that paddock. So they can use different varieties according to the growing conditions. So it's really quite a complex scenario, but the technology that farmers can use now really helps to identify what these issues are and really helps them grow crops efficiently. This last slide, while it looks a little bit busy and there's lots of different points here, can be broken down into a couple of things. If we look on the right-hand side and we look at data processing and analyze and yield weeds and topography and prescription maps, what that really shows to the farmer is what they should be doing, when and who and how. That is the, if you like, the guiding light associated with what they should be doing. The data that they're going to show there could be soil type, could be moisture profiles, could be weed profiles, could be insect issues. And also then that data can be then put into the various technologies that they have associated with fertilizing, planting, or spraying. And that information then is absolutely where it comes down to precision farming. You're putting the seed, the chemical, the fertilizer where it's needed and where it's going to provide the most, I'm going to say, bang for buck or bang for pound, regardless of where you are, but the most economical return. Right up the top there, we've got a little green person walking around scouting. As I mentioned earlier, we have a situation where this technology can provide information so the farmer then can act according to what's the best time, date, place to then provide extra fertilizer or address pests, etc. Right at the very top, this is the proof of the pudding. This is the success of all this process. The harvest then shows at the end of the season what the success has been, the yields in tons per hectare, per acre, etc., of the different crop. Most importantly, that data goes into the data processing scenario that can be used for the next year and the next year. So the farmer builds up a bank of information that they can use alongside their agronomists and their technical advisors to then continue to improve their farming production. So there's a range of different satellite-based tools that may be out there. There can be drones, the GPS systems, smartphones, apps, software technology. There's a whole range of things to be using. This is all what precision farming is all about. Okay, so I'm happy to answer any questions at this point, but if there aren't any questions, we can go back to you, Richard.
Thank you, Robert. What an insightful presentation. Thank you so much for sharing that with us. I have so many questions, but I'd like to just let the audience know now that we will take a live Q&A. So again, if you see in the chat box, you can type your questions there. I will be able to see them coming through and field them to either myself, Robert, or Andrea, if better suited. But I think, Robert, what I wanted to say to you whilst people are thinking of their questions is, welcome to the UK. I hope you're acclimatized. I don't know, did you come directly from the US or from Australia, Robert?
No, from the US, Richard. I've only been here 5 weeks, actually. So looking around for a permanent job as such. I'm actually born here, so I've got a dual passport. So, but agriculture and the sort of things that I've been doing, a lot of what I've been talking about here is international. All these challenges are faced by farmers regardless of where they are, regardless of the size and the type of operation. So, whatever that we can do to improve and assist that ensures that agriculture continues to be a vital part of every country's economic production as such, or economic scenarios.
Yeah, absolutely. And I omitted from my introduction, Robert, that actually I live in the north of England, what we call the Yorkshire Dales. I'm sure you're aware, but lots of grazing livestock, cereal farms, and famously dry stone walls. So I hope your next step takes you up to Yorkshire at some point. But we do have questions coming in now. So let me just pull out a few. What I will say to everybody on the call, if we don't get to your questions, don't worry. We will answer them offline and make sure that we provide feedback. So we'll start here, Rob. I've got a question from Jacob. Can you share and discuss any potential downsides or risks associated with using precision automation in agriculture, and how can those risks be mitigated?
Look, I think the scenario here is misinterpreting the information that you're receiving. And typically farmers don't necessarily make all these decisions themselves. They always rely on what I'm going to call farm agronomists or those sort of technical advisors. So how do you mitigate the risk? You then have an agronomist who helps you through the process. Okay, you've got a certain weed species that's the issue. Is it resistant to certain herbicides? What are the herbicides that you use? What are the rates that you use? So again, it's not only looking at that and sharing that information, but it's also going back in time and looking at the data and what you've done in previous years and saying, hey, this worked in the past, this will now work in the future. Or If you've got a real issue, get your agronomist or technical advisor to come up with other ways of managing these scenarios.
Yeah, brilliant answer, and a lot to think about there. I have another question from Poppy. It's a question actually that we see in many different industry segments that we work in, but many rural communities are afraid of robotics. Any advice in your experience around the world, Robert?
I think that comes back to the fact of labour. And one of the issues that was faced in the dairy industry is labour and reliable labour. And there is robotic milking systems now where the cows literally walk in and they get milked. No one has to touch the cow, and the cow actually becomes quite used to this sort of scenario. So I think it's a situation where farmers will then work alongside the different companies to provide those sort of products. And I won't suggest that the whole operation will go robotic at one time, because not every farm is the same. So the advice I'd give is that then robotics will take over slowly, but probably targeted according to the crop or the product that you're growing or the animal or livestock that you're running.
Brilliant. Yeah. Yeah, we're being flooded with brilliant questions now, Robert. You've really caught and spiked everybody's interest. I've got a great one here from Tom. He's asked about, what would you say is the general uptake of tech skills in the agricultural sector? Is there an expectation that there'll be more training, more development in this space as more technologies come through to help optimize some of the things that you talked about?
Tom, we could spend an hour talking about that. Let's distill that. What would you say is the general uptake of tech skills? If I used the GPS tractor analogy in the beginning, people were skeptical. Everybody now has a GPS tractor, and now it's moved on to self-driven tractors that farmers don't even have to get into. So that's changed. And I will say this, there's attitudes that drive farmers. And one of the attitudes is the business-minded farmer. The business-minded farmer, this is right up their alley. Anything that you can provide that gives them the ability to not only be more efficient, but produce more profit, they're going to jump on. And this is exactly the space they want. So is the expectation that the Internet of Things products and services are idiot-proof? Well, there's issues out there in some cases with connectivity and storage of data and people's comfort levels associated with various scenarios. But the other thing I will say, whoever they've bought the product from, they need training, they need a backup, they need service. So it's really important. You just can't sell a product and walk away. You've got to have technical backup to troubleshoot issues. And that's where these sort of products and services really come into their own, because there's a real bond created between the manufacturer, the distributor, and the farmer, because they work through those issues.
Yeah, absolutely. We will just take one more question, Robert, and then we will be looking to you to help us answer some of the other questions that are coming through now. But just one interesting topic that came through early from Sujith is wanting to know more about an explanation on the scarcity of water and the impact that has on some of the things you shared with us today.
If you put in place or address issues around climate change and variability of rainfall and variability of amounts of rainfall, that's all then impacting on the availability of water for irrigation purposes. The other thing I'll say that is a lot of the irrigation systems that have been set up were set up 30, 40, 50, 60 years ago. And that's when the population was way smaller. So any technology that looks at efficiency of water usage and or efficiency of then soil moisture levels then is really going to be looked at in the future. Really trying to evaluate and change all these watering systems is a huge job. There's again, this topic is a huge one, but scarcity of water and also efficiency of water use going into the future using internet-based technology is a huge opportunity out there, and it's only going to get more important.
Yeah, brilliant. I think, Robert, I just want to say thank you for sharing your experience and your knowledge in this industry. You've absolutely caught the interest of everybody listening to this webinar today. So thank you very much. Please stay with us. But I will now switch gears and hand over to Andrea. Again, Andrea, I hope that you can hear us and that we can hand the floor to you to share with everybody what Arduino is doing today in smart agri-tech. Thank you.
Thank you, Richard, and thanks for having me today. And so I call my session Smart Agri-Tech because Arduino has, this kind of DNA that makes things to accelerate business. We are talking about Arduino PRO, so we are talking with companies. We are talking, in this case, with the Smart Agri-Tech company, and of course, also end users, so the farmers. So our idea, coming from 15 years of experience in the maker space, in the education space, that we have now, we would like to have the same and provide the same philosophy also to the business. When it comes to the agri-tech, we have different options. So in this slide, you can see that we have mainly three different pillars. One is system on modules. I don't want to bother you so much with technology, but just to give you an idea on how companies and people that can use our technology. So we have system on modules that are in some way some kind of bricks. So imagine a brick, and around this brick, you can compose your application. That can be a wide range of and span different sectors. In this case, in the agriculture, you can start from a brain and then adding what you need for achieve your goal. So if I have to think about a business, a company that works into agriculture space, then Robert gave us a great insight in the different part of what precision agriculture is. So it's composed by different needs, different challenges, right? We talk about water consumption and water scarcity. We talk about data. So there are multiple angles where companies that start their business from. And using system on modules from us, they can, in some way accelerate their business ideas, then can iterate and then go and shrink the time to market. Then we have what we call the turnkey solution that are more slightly verticals, applications, hardware for applications. This means that we have alongside the system on modules these boards that are mainly ready to be used. And we have some of them in different business, different sectors. And we have one for agri-tech that comes basically from the feedback we have received from time to time, and then during the iteration stage of ideas and products creation, then we incorporated them to create a special, let's say, more vertical solution that can be used in conjunction with external sensors, in conjunction with external actuators, but they are meant to be used for a specific sensor. And then on top of all our hardware solution, we are well known for hardware solution, but of course, during the years, we added on top of the hardware also software. And in this case, we are starting from end to end. So we have the hardware part, and then we can also combine with services like cloud. Everyone talks about cloud, also in farming. Now, data are more and more important. So having a place, a secure place for having those data then it's a great combination of hardware. Without saying that everything should be smart, everything should be easier, because everything that can be useful for and easy to use and adopt, then at the end becomes a powerful tool for creating business around a specific sector. So when we talk about system on module, we have different boards. I don't want to go on all our product portfolio because we have a lot, but I would start just to give you an idea. Then on our website you will see more and more if you are interested in Arduino.cc/pro. But this one, the Portenta H7, is I would say that the first step when you have to have a product that is powerful, robust, open in terms of openness, in terms of open source, of course, but also in terms of open to new businesses. Because it has multiple ways to be connected to. It has microcontrollers that can be used for running, for example, machine learning tool, and then I will be on this later. It has Wi-Fi and Bluetooth, so there's no need of adding other external sensors when it comes to communication protocol. It's secure. Every connected Arduino board is secured by design, meaning that we have a secure element that can be used for protecting your data. So the data is the heart of every single application. Knowing data, collecting data, organizing data, everything. If you think it's around data coming from different sensors. So securing them in an easy way, and then letting people that are using data to be sure to be safe on those. In this case, it's really important. And the Portenta H7, it could be the brain. As I said before, we are an accelerator. We act as a building block for companies that want to integrate this solution into their end product. So the use cases, you can see, there are industrial machinery, laboratory equipment, computer vision, PLCs, robotics controllers. So you can see there's a very variety of usage. So next solution is regarding vision. So we have Nikla Vision. This is a really tiny board. It's only 2 centimeters per 2, so it's a little bit square that has a lot of powerful. And this with this board you can add, for example, machine vision. I will have also an example later on this. So this tiny board can be used for sensing and add vision application to your solution. So companies can use this board for adding machine learning vision at the edge. The next one, it's another board that it's specifically, and this is the vertical solution I was mentioning before. It's a vertical solution, so it's the Arduino Edge Control that is exactly tailored for the agriculture, Agri-Tech world. Can be used indoor, outdoor. It has already solar panel capabilities of being powered from. It has multiple connectivity options. We are thinking about in the agriculture, we have open space, large spaces. So communication, sending data from the field. In this case, the board can be equipped with different communication protocols. LoRa, narrowband IoT, of course, Wi-Fi when it's the case, 3G, so cellular connectivity. So depending on the need, you can evolve your product, or you can just adapt your product. we have different examples where companies started with this board with a specific part and then added later. So I will go in back later. The next one is some kind of glue when we talk about LoRa. So this is a gateway for adding LoRa technology and LoRa transmission in the field. So again, when I was talking about hardware, it was made of components at the different stage. So we have boards, we have in the middle, we have the gateways, and then we have the cloud. But I think that we can go on and let I will give you some example of actually our customer are using our boards. So this one, it's meshed farming. So before you heard about different ways of managing data and mesh data. So this is an example of a customer that uses our technology in conjunction with external data, for example, forecast for weather. So weather forecast combined with the real-time data in order to have a precision in terms of status of their crop. And then you can see in the map, adding GPS data, the company was able, for example, to predict the movement of some kind of weather condition, or more important, by measuring data from the soil, they would be able to prevent the usage of chemicals. Because in that sense, by meshing this data, they were able to understand if some kind of pest will appear or not. The second usage is around enriching data and how we can enrich data, for example, using AI, so artificial intelligence right at the edge. So again, with our boards, with the edge control, by adding machine learning on top of the data coming from the soil, then we can add enriched data and give lots of more information to the farmer, to the agronomist, and giving some more insights beside, the pure data that can come from the soil. The next one, it's traditional soil monitoring, and you can see here it's quite standard installation. In this case, there are also the possibility of having command and control. So monitoring data coming from the field and then going to the cloud, and from the cloud then also decide right straight from the cloud itself to the device, decide what to do. So open valves, start watering the plants, or in case of need, just close everything because weather forecast, would say that raining is arriving. So this is another way of using our products. And another one is hardware as a product. You can see here we have a blue box. Inside this box we have the edge control. In this case, the edge control was used leveraging some special watermark sensors that you can see on the right hand. This was used for analyze the soil in the tensiometry world. So I'm not a specialist of agriculture, but I learn a lot from our customer that it's always interesting to see how our boards are combined together to achieve some kind of specific result. So it's always amazing to see that what we thought and act as a neighbor, then at the end will become an idea, will become a product, it will become a solution that probably we never thought before. So it's always interesting to learn a lot. So giving us feedback, in this case, it was a specific question, how we can support those kind of special sensors. So this is again a way of using a more straightforward way our products. And the last, it's smart vision. I talked before about smart vision, and this is an application. So in this case, we are thinking about wired pest monitoring. So adding vision capabilities to the board, and then on the edge, so right on the board, right in the field, we can identify some specific bugs. This was used for detecting a specific bug and check and count them. So thinking about identifying some trend in order to prevent the massive existing of this bug. So this is again another usage, and the nice stuff is that you can combine all together. So you can see on your left hand side that you have one sector one with this field sector, and you have this IoT node that multiple IoT nodes can talk with the edge gateway, and the edge gateway can send your data to the cloud. So I think that are more or less in time. So I thank you for your time, and I give you back the word, Richard.
Brilliant. Andrea, it's so good to have you with us today. We will just take a pause now for the live Q&A. So everybody can use the chat box again to ask Andrea any questions. I'm not ashamed to say, whilst people are thinking of those questions, that I am a huge Arduino fan. Andrea, I could talk to you all afternoon about the meshed farming, AI farming, smart vision solutions that you shared. They are incredibly innovative and interesting. And I think, you know, Arduino is uniquely positioned to support Agri-Tech, from the system on modules, from the turnkey solutions, all the way through to the Arduino cloud. It's a very exciting proposition. So Andrea, I think we've got some questions coming through. Let me see what we have here. I think actually, whilst I'm waiting for them to come through, there was a question from Tom Guy. It was actually a question that was posed when Robert was talking, but it was actually about how open source hardware and software interact with each other in agricultural solutions. And I'm guessing you're seeing that more and more in the Arduino proposition, the software and the hardware between being so important.
Yeah, absolutely. That's a really great question. We are seeing, when it comes to open source or open versus closed source or software or hardware, we are seeing some kind of transition. So meaning that we see more and more different companies that open data or open the software, because they realize that at the end, this kind of culture, of sharing data, it's a win-win solution, right? So in this way, it's more easier and more possible either for the end user to give the best from each one, right? So having the best, having the data, and then of course it means that at the end, the final user is happier, right? And this it can be only doable with opening this data, opening software. We heard something around the word of people that are in some way upset because they cannot repair their things because everything is closed. So more and more we are seeing this culture moving forward.
Yeah, brilliant. Yeah, we've got so many questions coming through now. And I think I just want to say, Andrea, that you've inspired so many people. We're getting lots of comments that you've given them so many ideas to think about. But I just want to take a couple. So we've had a question here from Sajith. How is Arduino supporting renewable energy? How are your technology supporting renewable energy sources? Do you have a view on that, Andrea?
Yeah, well, as I said, it's we are not exactly, I would say, vertical in different sectors. So we do provide this kind of ability to innovate. We provide all the needed tools in terms of hardware, in terms of software for creating products. When it comes to renewable energy sources, I can say that I saw some project in the energy, in the photovoltaic and photovoltaic stations. We have actually a customer that it's creating. I don't remember exactly the name, but it was some kind of a group, the pool of photovoltaic systems, and they were asking us to create something to manage and optimize all the different sources. Another idea and another thing that came in my mind is that a customer wants to add value to his product when it comes to wind energy source. So windmills, and it was again some kind of improvement in terms of product. So when it comes to renewable, there's different ways of approach, and the nice thing is that we can provide all the building blocks that are quite open for as a DNA, so they can be used for almost everything.
Yeah, brilliant. I think that Arduino is the the king of open source, so no doubt there. We've got time for a couple more questions. I just want to take one from Stuart. He's put a brilliant question in here. It's, hi Andrea, are the Arduino products being applied to the circular economy applications such as emission reduction, carbon capture towards net zero objectives? Do you have a view from that from an Arduino perspective?
Yes, it's quite interesting because either internally, but of course with customers, the ability of having data around. So thinking about carbon zero objective, we are on our side. I would say they are really. Really sensitive to this kind of commitments, or when it comes to this kind of thoughts around sustainability in general. Then of course different ways of using our boards, different using our solution that could be applied in circular economy, because they really have some kind of ability to add value to this different application sector. And so also this, when it comes to renewable, when it comes to circular economy, carbon zero. So there are multiple ways to use it. So yes, absolutely, are applied that.
Brilliant. And I think just one more question, if we can, Andrea, and this comes from Tom. I think this is a great question. Obviously, Arduino is known for community. So Tom's question is, will there be some support communities from Arduino for the source code for the different applications, such as the sensor calibrations? Will that be available through the Arduino communities?
Okay, that's a good question. I would say yes. Meaning that the nice thing of Arduino is also, if you have a sensor and you write the name of the sensor and you Google it and then you add Arduino library, at 99% you will find something already there. So it's absolutely the proven that. Our community, it's really great, and of course we support the community itself by this giving stuff and get support, feedback, and of course code. And so yes, when it comes to specific sensor or third party sensor, because the possibility of support different kind of sensor, then of course It's more on the community side. We help usually when there are some issues. Of course, on our boards, we do provide all the libraries that are needed in terms of calibration. I'm just wondering, I talked last week for sensor calibration, for temperature sensor calibration. So also with the partnership with the vendors in Bosch or whatever it is, then we can provide direct support either from the vendor. So this is another good opportunity for us to give to the community.
Yeah, wonderful. So many questions. Everybody who's asked questions that we've not had chance to take directly, just remember we will come back to you, so don't worry. Andrea, I'll say thank you. Please stay with us. But if we now move on to the next part, I'd like to pull everything that we've heard today from Robert and Andrea. I'd like to just summarize a little bit with regards to what we, the team at OKdo, are observing, and what we are driving forward with our partners through 2023 and beyond in this very innovative and evolving industry. So I'd like to just share very quickly with you 5 smart farming technologies that we at OKdo are seeing as a transformation within the industry. And then I'd like to talk a little bit about the different platforms that we have from our partners like Arduino, but also from some other technology partners that we're now driving into different applications. So the first one I'd just like to touch on, and which Andrea gave us some real insight into, is sensors. And there's no doubt, you know, that agricultural sensors now, the data that they capture is providing invaluable information for the decisions that are being made in those businesses, in those farming industries. And we see that as something that we want to drive faster and with more innovation as we move forward. The second one that I want to share with you is robotics. Actually, I think we took a great question earlier on robotics and how it's featuring more widely across different industries. But obviously in agriculture, when we think about machinery and robotics, we often think about large scale machinery. But actually at OKdo, we are seeing much more streamlined, simple robotics linked to pick and pack, crop monitoring, and wider scale harvesting in controlled environments. This is again something that we are looking to enable through our technology moreover this year. The next one is drones, and we've touched on this already as well, but drones are helping farmers plan ahead. They're technologies now that are enabling farmers to harvest data in real time and to look at enhancing decision making, boosting productivity, and we're seeing drones being used in a multitude of different applications. One of the biggest that we see at OKdo with the clients and customers that we work with today is signs of disease, flagging where there is risk and where there is intervention required. If we move on, the next one is cloud software. And Arduino have an incredible cloud solution linked to all of their technologies, but specifically on their Arduino PRO Patenta range. But we are seeing software as being a pivotal part of agriculture moving forward. How data is obtained, how it's assimilated, how it's aggregated, and the dashboards that are then made available, empowering again the decision making that is needed in this fast-paced industry. And then finally, we also see an emergence of security technologies. This is a little bit different to some of the things I've already talked to, in that actually, as well as practical farming solutions, you know, smart tech is used on farms for automated security solutions. We're seeing more digitally advanced security set up from computer vision, from security breach detection, and also from protection through more generalized security features that are enabled digitally and supplied to the farmers and the businesses in a more intuitive way. And this is something, again, that we're seeing as a trend in the technology platforms that we're providing. So I said right at the start that at OKdo, we are very focused on single board computing. We're very focused on the platforms that can be scaled into different applications. And I just want to share with you a couple of ways in which the single board computers that we're using and working with today are supporting smart and precision agriculture. So the first one is data collection. Of course, these platforms are perfectly positioned to collect data from precision sensors and from other external components, and share that data in, like I say, in an intuitive software platform. They're used for monitoring, connected to cameras and other detection equipment that can feed back real-time information where it's most needed. And linked to that is the remote management. These devices do not need to be in a cluster, in a centralized position. They can be scaled remotely using different types of connectivity, such as LoRaWAN, long range, wide area, low power. And these devices are all being installed with this type of connectivity and technology. Crop optimization, monitoring again, adjusting temperatures in close control environments, ensuring humidity in greenhouses is meeting the recommended and ideal temperatures, making it an ideal growing environment for specific crops, and making sure that those crops are protected as much as possible from diseases that commonly are associated with them. Then finally, automation. SBCs automate farm processes. Irrigation, we talked about water scarcity, the management of irrigation, how that is managed at a system level. These platforms are helping. Fertilization, pest control, reducing manual labor and increasing efficiency, reducing error risk, are all applications that are possible from these devices, from Arduino and from the broader OKdo portfolio. And why do SBCs make the right choice? Why are they the right choice for this market? They increase time to market. Often single board computers are pre-designed, fully optimized with a range of software stack that can be designed directly into agriculture applications. The performance versus cost, because these SBCs are made in scale globally, they've already been optimized. So the cost of the microprocessors, the sensors on board, the memory configurations have already been completely optimized for the solutions that they're most likely to be used in. They offer engineering efficiencies. We often at OKdo talk about providing the path of least resistance for engineers in the field, and single board computers in their small form factor, low cost, high performance often speed up the design cycle by months, not just days. They sit as part of a wider ecosystem, and so I'm proud that we work with Arduino and offer such a broad array of system on modules, different processor types, and different accessories to support the designing, whether that be around power efficiency, whether that be around how information is displayed, or whether that be how we maximize computer vision technology in the smart agriculture field. OKdo, with support from Arduino, is ideally positioned to do that. And finally, we offer supply chain optimization. We offer our solutions globally with a global manufacturing footprint, and they're completely scalable. So we offer customization where what we might have off the shelf doesn't meet the end requirement. And so that's through design, services, configuration, and full customization of solutions. So it's a really exciting part of the innovation that we're seeing in smart precision agriculture moving forward. So finally, I just want to share with you that, you know, we've had the luxury of Arduino with us today, but at OKdo, we are incredibly focused on a handful of design-led technology partners. And I just want to share with you that, you know, Arduino Pro is an incredibly strategic partner. And we love to speak to any of you with regards to the challenges that you're facing, the innovation that you're bringing, and how we can potentially help with support from Andrea and the team from Arduino. But we also offer some incredible solutions from our partners NXP, supported by Polyhex, a range of single board computers based on the i.MX8 platform. We also work with Rockchip, a leading edge AIoT provider that opens up the spectrum of capability for our industrial customers, as well as some really innovative solutions around AI with NVIDIA, with leak detection, water detection, surface to cloud with Layer, and also with Google Coral and their TensorFlow solutions that are being used now across a range of agriculture applications. So I just want to now close the call, say thank you to everybody for joining. If you do have any questions for me or for any of the team at OKdo, you can get in touch with us. The contact details are now being provided. But I just want to say a big thank you to Andrea and Robert for the insight, and thank you for the engaging questions that you shared with us today. Thank you very much. Until next time, I'll say goodbye.